Today, the laws of logarithms. In this lesson, we will use 3 exponent laws to derive equivalent rules for use with logarithms. These new rules will give us significantly, like big time, more power when solving problems involving logarithms and exponents. Now, you can sort of picture this lesson as the trig toolbox sort of thing. The trig toolbox told you how to handle different situations with trig, whether it was adding inside sign or a double angle inside sign. The good news is, don't freak out, because the good news is there's only 3 log laws you got to worry about. And so when you're looking through it, you don't have to search through them. You just look at it and go, it's either 1, 2, or 3 that maybe I can use here. Now, the first part of this lesson isn't meant to prove the log laws. It's just meant to sort of give you a feel from where they come from and why the log laws work the way they do. And the way we do that is to talk about exponent laws, because exponents and logs are right tied together. So if we talk about the exponent law in each situation, we can immediately come up with a log law that we can use. So, way back in grade 9, you learned the first exponent law. It was called the exponent product law. And when you were multiplying 2 things, and listen carefully to my words because that's what matters, when you're multiplying 2 things, it turned into adding the exponents. So when multiplying became the operation of adding when to do exponents. The same thing happens with logs. The operation of multiplying inside a log can be broken into addition between 2 logs. Again, not a proof. All we're doing here is sort of saying, okay, if exponents work that way, logs will work that way as well. The proofs are a little bit complicated and a little bit too much for this course. So all we're doing is sort of showing where they kind of come from. Great news. Quotient law from grade 9, when you first learned it, turned division, yes, into subtraction inside the exponent. So the equivalent log law is when you have division inside a log, you can turn it into subtraction between 2 logs. Okay? And the third one was power of a power. In grade 9, you learned that when you have an exponent to an exponent, it turned into multiplying up there. And so that's what happens here. And this is the most important of the log laws. It kicks off tomorrow's lesson, is that if you have an exponent inside a log like this, you can bring it out front and make it multiplying like that. Okay? All right. If you're a little confused about those or where they come from, don't be yet. Let me finish the lesson. What log law 3, log law 2, log law 1. Those are the 3 log laws we can use to solve problems. And what I'm going to do is sort of show you one of them in action. I'm going to write the log law out each time so you can see exactly what's happening. Again, those 3 highlighted things are like your log toolbox. This is what you can do with logs. Okay, on a separate page, use logarithm laws to simplify each of the following. So this is addition of 2 logs, 2 separate logs. Now take a look at these. Where was there addition of 2 separate log laws? Log law 3 doesn't have addition of 2 separate logs. Log law 2 does not have addition, but log law 1 does. And look at, we're going from this way to this way. We did a lot of that in trig, where we went from the right-hand side to the left-hand side. So I'm going to write the log law right underneath it here. The log law we're going to use is log a of m plus log a of n has to come out to log a of mn. When I explained the law, I said multiplication inside a log had to become addition of 2 separate logs. Here we're just using it backwards. So just following the exact pattern we see there, that means that the log base here is 4. So on the right-hand side, I've got to a single log with log base 4. And I've got to multiply the 2 things that were inside the logs, the 32 and the 2. So I'm going to write 32 times 2 in there. And what I get is, I'm going to put a little box around this. It's not really part of the solution per se. It's just what I'm using to get the answer. And so now, that becomes log base 4 of 32 times 2, which is 64. Now when this question started, doing log base 4 of 32, there's an answer to that, but it's not simple. Like 4 to the power 2 is 16, 4 to the power 3 is 64. You see, it's somewhere between 2 and 3 as some kind of decimal number, which, again, we'll get to being able to do these on our calculator and get the decimal answers. We'll get to that in tomorrow's lesson. But for now, that's not a very friendly log, but look what happened when I multiplied these two things together, 32 and 2, I got 64. That is a very friendly log. The exponent you put on 4 to get 64 is 3. 4 times 4 times 4 is 64. So that's one good reason to use these log laws, is you might get something you can work with. Okay, another example here. This one uses subtraction, so the important log law is log a of m minus log a of n can be put together with division. If you look above on the note there, you'll see that that's the log law when you have subtraction. So this time it's going to become log base 2, but I'm dividing the two things inside the log, and I get log base 2 of 2. I set this up on purpose. This is a very, very easy log, and that it's so hard, or sorry, it's so easy that makes it difficult. You need the exponent you put on 2 to get the number 2. What exponent do you put on 2 to get 2? Well, that's the number 1. So that can be a challenging question. So I've demonstrated log law 1, I've demonstrated log law 2, and now log law 3. Now I'm going to put log law 3 over here so you can see exactly what it says to do. It says if you got log a of m to the y, you can turn that into, you can bring the y out front and make that y log a of m. You can do that. If you want, if there's an exponent inside a log, you can bring it out front as a multiplier. How does that help here? This doesn't even have an exponent in there, and this log 2 of root 8 is very, very difficult because of that root. But watch what happens if I write 8 to the 1/2. That's what root 8 is. Square root of 8 is 8 to the 1/2, and that puts that up as an exponent, and now I can use log law 3 and bring that exponent out front. How nice is that? That complicated square root part became a complicated 1/2 part, which moved out front to become a multiplier of 1/2. This is such a great move in logs, and you have the ability to do this with this third log law, is the ability to take square roots or exponents and just move them out front and not have to worry so much about them. And then what I get is 1/2. Log base 2 of 8 has now become a friendly log. What exponent do you put on 2 to get 8? Well, that's a 3. And then we need 1/2 times 3, which is 3/2. So this became very friendly using log law 3. If you had to have a favorite log law, it should be the third one, because that one is the one that takes really awkward situations and cleans them right up. Now, while those examples show the power of log rules, the examples that follow are even better. Look at this mess. Log base 3 of x equals 1/2 log base 3 of 36 plus log base 3 of 18 minus log base 3 of 2. What a disaster. However, using the log laws, I can do some things. And getting used to how the log laws work and how they can be used is difficult, but that's what I'm showing you here is some of the things that you can do. The first thing is, in the last example, having the exponent on there, we decided that was not the greatest thing, and we moved it out front. And sometimes that's the thing to do. But sometimes it's the opposite that is the great thing to do here. And the reason it was better out front on this example up here was because finding the square root of 8 was not easy. Okay? And that's pretty much the whole story. Because square root of 8 was difficult, we moved it up as an exponent and moved it out front. In this case, though, check out what that thing is. If I go the other way and use the log law 3 backwards and say, no, I don't want it out front as a multiplier. I want it inside as an exponent. Look what happens. Square root 36, which I can evaluate. So that's the whole decision about why you would want to move it out front, or why you'd want it as an exponent is, hey, which one's going to work better? Which one's going to make a simpler problem? In the last problem, it was simpler when the exponent came out front. But in this problem, it's simpler this way. And the reason I say it's simpler this way is that the square root of 36 is 6. And how nice a number is that? That's pretty well behaved. Well, maybe you're unimpressed at that point. You're like, well, that really didn't accomplish too much. It did accomplish a lot, actually, if you look, because what happens is I can use log law number 1, which on this part right here, I'm going to highlight it, this part right here, which says you can take the addition of 2 logs and put it together as 1 log, but now it's going to be multiplying. And so things have really improved here. 6 times 18, get your calculator out, 108. So things are a lot simpler. And now I've got subtraction of two logs, which is log law number 2. And log law number 2 says if we want to put those together with subtraction of two separate logs, you got to do division inside. And that whole thing I did actually has a name for what I did, is I expressed as a single log. That is a move that you'll see in the homework too, when they ask you to express as a single log. And so what I did there was I did all of that work using the 3 log laws to express it as a single log. And once it's expressed as a single log, why is that such a great thing? Well, log base 3 of x equals log base 3 of 54. Therefore, x equals 54. The logs drop off. If that is weird to you, we'll take a look. We want these two sides to be equal. The logs are equal. The bases are equal of 3. So I just need the insides to be equal. And so I need x to be equal to 54 to make these two sides equal. Okay, another very similar example here. This one, I could go ahead and use log law 1 and log law 2, except for this out front, which is not a complicated number. 3 is a nice number to use, so why not use it as an exponent instead of as a multiplier out front? So that's what I'm going to do. And why I say it's nice is because I can evaluate that. It's not weird like that root 8 was before. What the heck happened there? A log base 5, okay, of 8. You know, that's a nice number to deal with. And then I can use log laws on either side. On this side, 2 logs being subtracted becomes subtraction. On this side, 2 logs being added becomes multiplying. So that's 6 times 8 inside there. So I get log base 5 of x over 8 equals log base 5 of 48. And again, because I've expressed them both as a single log, it's such a great move when you express them both as a single log. Now they're both log base 5, so the logs are equal on both sides. The base of 5 is equal on both sides, so all I need is for the insides to be equal. I need x over 8 to be 48. I can solve that pretty easily. 48 times 8 is 384. Okay? So we are the log laws move us to be able to solve equations, and tomorrow even to be able to solve exponential equations. We'll show you even more. Tomorrow's the best of the log lessons for sure. But move through this. It's important to be able to maneuver the log laws moving forward, and especially in science, but in math, of course. Move through that homework. We're almost done. Get through this stuff so that you're ready for tomorrow's lesson. Have a great day.